Systems of Non-linear equations. This goes along with homework number 2. And I wanted to look at a few of these. The other video went over how to solve these graphically. And now we want to look at how to solve these algebraically. We'll look at just a few of these examples from the notes. This is number 5. To solve this algebraically, we have this equation and this equation. This is probably the easiest type where both of these are set equal to y. So we can do substitution and let's see, I'm just going to take y is equal to this, and then I'm going to substitute it in for the other y. So we'll end up with x squared plus x minus 2 equals 1 minus x. And then we'll solve this. Let's see, this is a quadratic, so I want to get 0 on one side. So let's see, I'll add x to both sides. So I get x squared plus 2x and minus 1 from both sides, minus 3 equals 0. So now I can factor that. X plus 3x minus 1 equals 0. So x is going to equal negative 3 or 1. So our solution here, we know the x coordinates, negative 3 and 1. And now our y coordinate, well, we know y equals 1 minus x. So if x is negative 3, the y coordinate is going to be 1 minus negative 3, or 4. And for this one, we still know, y is 1 minus x. And so if x is 1, and we have 1 minus 1, our y coordinate is 0. So these are our two solutions, negative 3, 4, and 1, 0. Those are our two solutions. Graphically, that would be the 2 points where the graph would intersect. Okay, well, let's take a look now at number 7. And here we have number 7. Once again, we want to solve this algebraically. So I'm going to solve one of these equations for one of the variables. So I'm going to go down to this one. This one looks easier to solve for one of the variables. Let's see if I just solve this for x. It doesn't matter which one, but if we solve this for x, we'd get, 3x equals negative 2y. So x would equal, divide by 3, negative 2/3 y. So now we need to take this and substitute it into the other equation. So let's see, this would be x squared, but once again, I solved for x. So instead of x, I'm going to put this in. So I have negative 2/3 y squared plus y squared equals 52. And if I go ahead and square this, let's see, that'll be 4/9 y squared plus y squared equals 52. Well, if I add like terms together, let's see, I have 4/9 y squared plus 9/9 y squared. So I get 13/9 y squared equals 52. And if I multiply that by the reciprocal, 9/13. And let's see, 13 goes into 52 4 times. So y squared would equal 36. So you don't even need a calculator if you do some simplifying here. Well, then y is going to equal plus or minus 6. Please don't forget the plus or minus, or you'll lose one of your solutions. So our solutions then, we have a y coordinate of positive 6 and a y coordinate of negative 6. And then to find the x, we have our formula here. X is equal to negative 2/3 times whatever y is. So times positive 6. Oops. And let's see here, we would get negative 4. And right here we have negative 2/3 times negative 6. We get the same thing except for positive 4. So our two solutions would be negative 4, 6 and 4, negative 6. Those would be our two solutions. And let's look at one more. If we look at number 8 on the notes, and there's something a little bit different about this one, which is why I wanted to do this one also. Normally we solve for either x or y, but we don't really need to, as long as we have something we can substitute in the other equation. Like here I have y squared, and here I have y squared. So there's really no reason I need to actually take that to y. I don't need to take the square root of that or anything. That's the only y I have in here, and it's squared. So then I can just take out the y squared and put in 2x plus 13 in its place. And then don't forget everything else that we have. So once again, we just substituted. We just took 2x plus 13 and substituted in for y squared. That worked in this case because now we have all x's. Now we have all x's. The only y that we had was squared. So that's why that worked well in this problem. And now we know how to solve this. This is a quadratic. Let's add like terms together. And then let's see if we can factor this. So we end up with x of negative 6 and negative 2. But once again, please don't circle that. Don't say that that is your answer, because that's just our x coordinates. So we have x coordinate of negative 6, and we have an x coordinate of negative 2. And now we have to solve for y. So we know that y squared equals 2x plus 13. So y squared would equal, let's see what, negative 12. If I put negative 6 in there, negative 12 plus 13. So y squared would equal 1. Well, if y squared equals 1, then y is going to be, take the square root of both sides, plus or minus 1. And let's do the same thing here. We have y squared equals 2x plus 13. I'll write that out again. And now we're going to plug in negative 2 for x. So y squared equals negative 4 plus 13. So y squared would equal 9. So y would equal plus or minus 3. And I'm okay if you list it like that, but all together you can see that we actually have 4 solutions. Our 4 solutions would be negative 6, 1, negative 6, negative 1, negative 2, 3, and -2, -3. Those would be all 4 of our points of intersection, our solutions. You can either write it like this or like this, but as long as you realize that you do have actually 4 points of intersection or 4 solutions.